Good afternoon, everyone. Let's start. This is BBB 2025 final round mock review. This is primary four. All right. I hope you're in the right classroom. So let's start with our session today. So, with just few classroom rules, I encourage you to please be on time, especially during our break later. Please be attentive throughout the session so you can make the most out of the time here. Um, I do encourage you to open your camera and mute your microphone. And lastly, please chat responsibly. Refrain from spamming the chat box. All right. And lastly, annotate only when allowed. Right. That's it for our reminders. Let's have number one. Okay. So we have a question. Find the unit digit of 2012 multiplied by 7 that is raised to 2012. All right. So for questions like this, again, it's just the unit digit that we're after. So you can basically multiply 2 and 7. 2 times 7 is 14. So the unit digit is 4. So it's only 4 that we're concerned with. Raise that to 2012. All right. Now let's find the pattern for 4. Right? So to look for the pattern, we have 4 raised to 1. Okay, when 4 is by itself, we only have 4. When 4 is squared, that is 4 times 4, that will end in a 6. Okay, 4 cubed, okay, when you multiply that, 16 times 4, you'll get 64. It ends with a 4. And then when you have 4 raised to 4, you know it will end with a 6. Okay, because 4 times 4 is 16. So the pattern is basically 4, 6, 4, 6 every two numbers in your exponent. So 2012 is even, meaning it's divisible by 2. Automatically, we know that the answer should be 6. Right? Because again, 2012 divided by 2, because there are two numbers in our pattern, you'll get a whole number, 1006. Now, if you have 1006, that's even, you'll eventually arrive at this value, right? If you count 1, 2, 3, 4, 5, 6. Okay, 1006 is even, so it will end at 6. So the unit digit is 6. That's it. All right, that's it for our number. Let's proceed to the next one. All right, I see correct answer. Good. So find the value of 31 going to 60. So from 31 going to 60, notice that the difference is just 1 going to the next number. This is still considered an arithmetic sequence. And once we have an arithmetic sequence, um, we can actually use the formula. The sum of an arithmetic sequence is equal to last the first divided by 2. Okay. And then that's last minus first divided by the difference. Okay. The difference is what number are we adding to get to the next one, right? Plus 1. All right. What we know is that the last number is 60. The first number is 31. And then divide that by 2. Copy the 2 because that's our formula. The last number is again 60. The first number is 31. The difference is just 1. We can also choose not to write it anymore. Plus 1. All right. So from there, 60 plus 31, that's 91 divided by 2. Let's not divide it yet because it will result to a fraction. 60 minus 31, you'll get 29. Plus 1, you'll get 30. 30 divided by 2, you will get 15. 15 times 91. All right. Again, 91 times 15. You'll eventually have an answer of, let's double check the value. Okay, 1,365. Okay, our answer should be 1,365. That is making use of the arithmetic sequence sum if you only have an arithmetic sequence. All right, that's it for our question. Let us proceed to the next one. Number 3, if two rats can have two baby rats for half year, there are 160 rats in January 2009 at Ming's home. How many rats are there at Ming's home in July 2007? Again, two rats can have two baby rats for half a year. There are 160 rats, right? So from that given information, you know that will start at 160 for half a year. Okay? For half a year. Remember 2009. Um, let's go back to 2008 and then let's go back to 2007. All right? So this is basically if it's January 2008, that's 1 year, right? But if you go back on July 27, that's just half a year. Okay, that's just half a year. So 1.5. Remember, when you have half year, okay, our 160 result, divide that by 2. That's half a year. Okay? Divide it by another 2. That's already 1 year in total. Divide it by another 2. That's 1.5 year. So, in July 2007, 160 divided by 2, or we can just think of 16 divided by 2, that's 8 or 80. 80 divided by 2, that's 40. 40 divided by 2, that is 20. All right? So that is our answer. There are 20 rats in 2007. All right? Great. I see correct answers. Not 25, but 20. Okay? That's it. Let's proceed to the next one. Number 4, a stationery store only offers 2 types of stationaries, pencils and rulers. One ruler costs $4 and one pencil costs $5. Okay, let's write that down. Ruler is 4 and then the pencil costs is 5. If the stationery store gets a total of $157 for a number of stationaries, we don't know what number it is, but the total is the $4 times the number of rulers sold plus the $5 cost of the number of pencils sold is equal to 157. The number of rulers sold, okay, the number of rulers, that's R, sold is, when you see the word is, that's an equal sign, 3 times the pencil, 3 times 1 more than, 3 times and 1 more than the pencil. All right? So that is 3P plus 1 because it says 3 times and more than 1. So from that information, we could actually have 157 Okay. 157 minus 4. 157 minus 4 will give you 153. All right. So from that, you'll have from 153, you can actually just divide it by 3, the quantity of 3 times 4 plus 5, all right, equals a certain number. 3 times 4 is 12 plus 5, that's 22. 153 divided by 22. Let's double check the value. Okay. You'll get an answer. There's something wrong. Okay, let me redo this one. Something's amiss. So let's replace this R right here with 3P plus 1. So that's 4 times 3P plus 1 plus 5P. We're looking for the pencil, so it's good that we have P's right here we can see. All right. So from there, 4 times 3, 12P. 4 times 1, that's 4, plus 5P. All right? And then that's equal to 157. Remember, let's transfer this to the other side. 157 minus 4, that is, so let's put it here. That's 153, same with earlier. 12 plus 5, 22P. All right. 22P. I know, no, sorry. My bad. That's why I'm having a wrong answer. 12 plus 5 is 17P. All right? 17P is equal to 153 divided by 17. So that's 12 plus 5, 17. 153 divided by 17. Okay, we'll give you an answer of 9. I wasn't careful. P is equal to 9. So the number of pencils is what we're looking for, and P represents for the number of pencils. So the answer is already 9. We don't need to solve for anything here else. We can stop here. Okay. If you have the question, let's proceed to the next number. Five-digit number 79A70 can be divisible by 9. Find this five-digit number. All right. So for this number to be divisible by 9, if you add all of the digits, the sum must be divisible by 9. All right. 7 plus 9 plus A plus 7 plus 0. This will give you 7 plus 9, that's 16, plus 7, that's 23. So you have 23 plus A. The closest number that we could have that is divisible by 9 is 27, right? We could also have 9, 18, 27, 36. Let's check. If 23 plus A equals 27, A must be equal to 4. If 23 plus A equals 36, that's already A equals 13. A is a one-digit number because it says that it's only a five-digit number. Okay? So it must only be a one digit, and the only possible value is when A is equal to 4. But the question, careful, ask us for the 5-digit number. It's not the value of A, but the 5-digit number. So you're gonna write 79 for 70. Careful with what is asked, okay? Great. No, the answer is 79,470, not 4. All right? So careful with what is asked. That is it for number 5. Let us proceed to number 6. Okay. So you have Ming takes 10 subjects for exam. The average is 68. After that, Ming discovered the mark for Chinese is not correct. After correction, the new mark of Chinese is 70 and the new average is 70. What is Ming's score for Chinese originally? All right, let's do this one. You have 10 subjects. The average is 68. So to get the total sum, you need to multiply average and the count of subjects. Okay, the average and the count. You need to multiply that one to get the sum. Average is 68. The count of number is 10. So you have 680 as the sum. Now, um, the new mark of Chinese is 70 and the new average is also 70. How are we going to answer this question? Actually, we're going to do it like this. We could have, this is the sum. Again, the new mark of Chinese is 70. We could actually start there. All right. And the new average is also 70. So from that 680, you need to have 70 minus 68. Multiply it by 10. All right. That's the number of subjects. So this is now the new average. That's equal to, if you check, 70 minus 68, that's 2. 2 times 10, 20. 70 minus 20, you'll get an answer of 50. This is now our answer, 50. All right, for number 7, we have the following question. Okay, there are 4 prime numbers. Their sum is 51. What is the maximum product of these 4 numbers? So, a prime number that is less than 51, 2 is prime. And highest prime, 37 is also prime, right? And what else? Oh, but if we have 37, it's already too big. You can't get 51. So the best set of numbers by trial and error is you could actually have 2 plus 13 plus 17 plus 19. If you check that one, you'll have 9 plus 7, 16 plus 3, 16, 17, 18, 19 plus 2, 21. Plus the 30 here, that's 51. All right, so this number works. Now, you want them to have the maximum product. Remember, when you want the maximum product, the numbers must be as close as possible. That's why we have 13, 17, and 19 right here. All right. So from there, you can have 2 times 13 times 17 times 19. That's equal to 8,300. 98. All right. Okay. For sure, we could have 2. That's a prime number, least prime number we could have. The other numbers must be close to each other as possible. So what we do is usually the sum minus the 2, you'll have 49. Then evenly divide 49 by 3. 49 divided by 3 is roughly 16 remainder. 16 remainder, a certain number, right? But 16 is not prime. But what are numbers close to 16? We have 13, 17, and 19. And we've chosen this so that when we add it to 2 also, we'd get 51. And so here are our numbers, all right? That's it for this number. Let's have number 8. So fill in the addition sign or subtraction sign inside the boxes provided such that the equation holds true. So you have here, we can actually do plus in everything first. So to check what's the maximum value we could have. All right. So to check, we could have, okay, if we add all of them up, you'll get an answer of, okay, this right here. So you'd have an answer of 93 if it's all addition. But it's only just 63, so we need to subtract it by a certain value. So 93 minus 63 is actually, let's write it down. 93, that's the largest value we could hold, minus 63, this is the value that we're gonna subtract. 93 minus 63, that's 30. All right? But we don't see a 30 right there, diba? So, divide it by 2. Let's check the closest value. 30 divided by 2 is equal to 15. So, the value that we're gonna put a subtraction sign is actually 15. Right here. Oops, right here. So, that's plus, minus, plus, plus, plus. All right, let's double check. 13 plus 14, that's 27. Minus 15, that's already 12. Plus 16, that's 28. Plus 17, that's 45. And plus 18, that's 63. So that is our number 8. That's how we answer questions like number 8. That's it. Let's proceed to the next number. Select some children from 10 children for one champion, one first runner-up, one second runner-up, and one for merit award. So how many different combinations are there? So it's different combinations, and you have 10 children. That means to say, one, two, we have a space for the champion, a space for the runner-up, the second runner-up, and the merit award. So we have 4 spaces that we need to fill. In the first one, the champion can only be one out of the 10 children. But then if we've already chosen one out of the 10 children, we now have 9 left for the first runner-up. And then 8 left for the second runner-up, and 7 left for the merit award. If you do that, 7 times 8, 56. 56 times 9, that is 504, times 10, that's 5,040. All right? So the answer is 5,040. Okay, if you have no questions, let's proceed to number 10. Okay. All right. Correct answers in the chat box. Good. So we have here, it says a 246-meter long train uses 300 meter per minute to pass through a bridge. It requires 4 minutes 30 seconds. What is the length of the bridge? All right. So again, we are given this information. So 300 meter per minute pass through the bridge, and then it only requires 4 minutes and 30 seconds, or that's 4.5. Half a minute, 30 seconds is half a minute, so we could say 4.5. So the number of meters is 300 times 4.5. Let's show how to calculate this one. Set aside the zeros. We'll deal with them later. 3 times 5, 15. Carry 1. 3 times 4, 12. Plus 1, that's 13. All right. So you have one, two zeros. Remember, you have one decimal. So there must also be one decimal here. So that means to say you have 1,350. So it requires 4 minutes, 30 seconds. But you already, that's in meters, but you already have 246-meter long train. So subtract that, make sure to subtract, and you'll get an answer of 1,144, the height of your object, the length of your object. So that's it for number 10. All right. For number questions 11 to 20, this is section B already. This carries 5 marks in the exam. So find the value of this one. Remember, it's a parenthesis. I know, it's PEMDAS. So a parenthesis within a parenthesis, we need to deal with the innermost parenthesis first. All right. So 3 times 4, this is innermost, that's 12. 6 times 8, that's 48. And so you have 2 divided by 12. 1 times is basically the same thing. We can just disregard it. Okay, 2 divided by 12 divided by 4 divided by 48. These are in parentheses. So we could actually write it like fractions. 2 divided by 12 divided by 4 divided by 48. Remember, when you have a fraction within a fraction, we can actually make use of KCC, or keep, change rule. Keep the numerator of our main fraction. Okay, that's the numerator, keep it. Change the operation to multiplication, because this was supposed to mean division. And then change the denominator to its reciprocal. We're just gonna flip it. Okay? So from there, 48 can be expressed as 12 times 4, right? And 4 can be I know, that's already enough. So 12 times 4, we have 12 times 4 in the numerator, and in the denominator, you'd end up with an answer of 2. Do we have the same answer? All right, I see correct answers in the chat box. Great. We'll have number 12. So for number 12, according to the following pattern below, find the value of a plus b. So you'll have, anyone who knows what's the pattern? No one knows the pattern. All right. So, yes, Nicolo, you have something to say. Nicolo.
Um, um, yung the only pattern I see is the top right and top left multiplied to each other becomes the bottom left. So that's the only pattern I see. I'm still trying to figure out how they got 9 po. 9, 6, and 8 po.
I see. So, thank you for that, Nicolo. This one, for sequences and pattern questions, make sure it works for everything, or else it's not the correct pattern. All right. I think someone raised their hand. Daniela, was it? Let me double check. Danielle, rather. Danielle.
Okay, so what I did is I times 2 and 3, which is 6. And
Mm-hmm.
then I did 6 plus 3 is 9. And then at the second one is 3 times 4 is 12. And then 12 plus 4 is, wait, off. Got the pattern.
I see. All right. Anyone else who would like to try? Anyone perhaps who knows the pattern? Okay. Let me. Yes, Jaden.
I think it's so you start with the top two, which is 2 times 3, which is 6. And
Mm-hmm.
which so 3 times 4 is equivalent to 12. 5 times 3 is indeed equivalent to 15. 2 times 6 is also. So that means it all checks out. That means so A is 12. Now to find B, this is what I did. I did the can I annotate? But
Sure.
I did this. I did top right multiplied by bottom left, which gives you 18 divided by top left, which gives you 9. But, wait, but for this one, wait, 45, 5. This one does not, uh, this one when you multiply it by 45, this one only gives you 9, which is not 8. So I'm assuming this pattern is wrong. But, but, um, yeah, I think I'm gonna keep on looking.
All right. Okay. It's good. You found 12 divided by 6, 2 times 2, 4. So it's not the right pattern. Anyone else who'd like to try? The answer is, yeah, the answer is 20. Actually, A plus B should be 20. So if A is 12, yes, Jason. Jason. I see. B equals 8. Mhm. What was that?
2 plus 6 equals 8. So that
All right. That must be 8. But how will we get 8? All right. Anyone else? No one? Okay, so here, the pattern actually among everyone who shared their ideas, for A, that was already correct, actually. So it's just that for B, what we're gonna do is this one. Multiply the top numbers, okay? Then add the right number, top right number, right? Add the top numbers, then multiply the top right number. So 2 plus 3, 5 times 3. Oops, something's wrong. Multiply first, then add, sorry. Okay, multiply first, then add. To multiply first, that's 2 times 3, 6, plus 3, 9. You'll get 9. Here, the next one, you have 3 times 4 plus 4. 3 times 4, 12 plus 4, 16. But we were only writing the one digit, the unit digit part. Let's proceed. If we have the same pattern for everything, 5 times 3 plus 3, 5 times 3, 15 plus 3, 18. It's 8. All right? So it works for the 3. That means to say it must work for the last one. So you have 2 times 6 plus 6 is equal to 18. So that means to say the B right here must be equal to 8. And the A is equal to 12. Again, the A was from 2 times 3, that's 6. 3 times 4, 12. 5 times 3 is 15. This is also 2 times 6, 12. But remember, we need to add them. 12 plus 8 is 20. So the answer should be 20. All right? We were close to that. That's it for our question. Yeah, it was only the unit digit. We must find the pattern. Okay, that's it. Let's have number 13. So for number 13, yes, Cassie, would you like to share? Is it still there? Would you like to share? All right, I misclicked maybe. So let's have here, Grandpa gives red pockets to his grandson and granddaughters. If he gives 2 red pockets per person, he will have 33 remaining. If he gives 5 red pockets per person, he will still have 9 remaining. How many red pockets does Grandpa have? All right. So for questions like this is somehow similar to, yeah, somewhat similar to what we've had before. This one, there's just 33 remaining, right? So we have 33 remaining. And then the other remaining 9, subtract it. And then 33 minus 9 is, that's just 24, right? So now that 24, divide it. Okay, let's write the complete equation. 33 minus 9, the remainders, divide it by the difference. That's 5 minus 2. What you divided it with. All right? So 33 minus 9, that's 24. 5 minus 2 is 3. 24 divided by 3 is 8. So that's 8. Multiply it by 2. All right? and add 33. Okay, so we're multiplying it by 2 because we have 2 red pockets per person. And then you add 33 because there were 33 remaining. So 8 times 2 is 16 plus 33, that's 49. 49 is our answer. Right? Again, the remainder, subtract them divided by the difference of pockets. That's 5 minus 2 in the denominator. Then simplify, you'll get 8. 8 is our initial answer, but we're not yet done. We want the original red pockets. So 8, multiply it by 2 red pockets per person, making use of the first sentence. 8 times 2 plus the 33 remaining. You'll have an answer of 44. Sorry. 49. Not 44. 49, my bad. 49. Ayan. Eight times 2, 16. 6 plus 3 is 9. 1 plus 3 is 4. So it's 49. All right? That's it for this number. Let's have number 14. So for number 14. All right. So we have here, there are 10 keys and 8 locks. There are 2 extra keys that cannot open any locks. Other 8 keys can open 1 unique lock. How many times are required to find out the extra keys? Okay. So for questions like this, it's just like this. So there are 10 keys, right? And 8 locks. But other 8 keys can open 1 unique lock. To find out the 2 extra keys, we're gonna start at 9 plus 8, decrease it down, right? Plus 7, plus 6, plus 5, plus 4, plus 3, plus 2, plus, yeah, until 2 only. And that's equal to 44. And that is how we get our answer. All right, for a while, let me double check. Okay, let's set them aside for now. We have that as our answer for the meantime. And then let's proceed to number 15. So for number 15, we have find the value of this expression right here. Notice that we're starting at 2, increasing it until 20 by 2's, and then we're gonna decrease it to 2 again. All right. So, but we're adding them. All right. We're trying to get the sum. That's basically an arithmetic sequence. The first part is an arithmetic sequence, we're just gonna multiply it by 2 to include this one. So sum first, the sum would be the last, okay, the last number in this first part is 18, right? 18 plus the first 2 and then divide it by 2, multiply it by the count of numbers, that's 18 minus 2, last minus first divided by 2 plus 1. All right? So this is only for this part right here. So let's check. 20 divided by 2, that's 10. 18 minus 2, that's 16. Divided by 2, that's 8 plus 1, that's 9. So you have 90 as the sum for the first part. So if this is 90, just multiply it by 2 to get the other part. So that's 90 times 2, 180. But you still have the 20. So 180 plus 20, you have an answer of 200. All right. Final answer is 200. Do we have the same answer? Okay, great. We have the same answer. Yes, that's it. Let's have number 16. For number 16, put numbers 1 to 9 inside the magic square below. Each number will appear once within each column, each row, and each small box. Find the value of S. We're basically like doing Sudoku here. So, anyone who has an idea? No one has an idea. Nicolo?
It's like Sudoku po, or it's Sudoku po.
Yeah, right? Would you like to share how we get the answer here? Any idea? Care to explain? No idea? Wait,
In each row, column, and each 3 by 3 square, if it's a 9 by 9, has to have the numbers 1 to 9 without any repetition in one row, one column, and one square.
Mm-hmm.
One 3 by 3 square.
All right, so how do we arrive at an answer?
So first we need to get the column or row with the most numbers.
Mm-hmm.
Then using the other numbers from the other rows and columns, um you should get the missing numbers, and then if you complete one row or column, you should repeat the steps again.
Yeah, that's great. That's how we do it. So, to really get the answer here, we can actually try to check which numbers are present and which are not. So S cannot be, we know for sure that S cannot be 2, 3. Okay, because we have a 2 here. Okay, let's show it, huh? Okay, S right here cannot be, okay, look at the column of S right here. So it has 2, so it cannot be 2 anymore, S. 3, it cannot be 3, 5. It cannot also be 6 because look at the row of S. All right, you already see an S. So there, it cannot be a 6, 2, 3, 5, 6. It cannot also be a 7 because inside this 3 by 3 square, we already have a 7. We cannot repeat that. There's also an 8 in that 3 by 3, so 8 is out of the option. 9 cannot also be there because look at that row, we have a 9 there. So S can only be 1 or 4. All right, we've narrowed it down. So how do we identify whether it's 1 or 4? Let's see. So if this is 1 right here, okay, this is 1 or 4. If this is 4, let's start with this being a 4. So if that is a 4, all right, and then this is a 1, a 2 cannot be here. Okay, we have a 2 here. Okay, let's try to place 1 here. 1, 2 cannot be in the second row, in the middle row. It cannot also be here. So 2 can only be, it cannot also be here. So 2 can only be on this spot right here. All right? So that's 2 for sure. So let's do trial and error to get the answer. So if that's 2, then this is 4. We have a 3 already. The 1 can only be placed right. Okay, 1, 2, 3, 4, 5. If we have a 5 here, because there's already a 5 right at this column. Okay, that's 5. It works so far. 5, and if we have a 6 here, 7, 8, and if we have a 9 right here, and this is the 1. All right, 1, 2. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's double check. 1, 2, 3, 4, 5. Okay, we'll be playing Sudoku. So this is quite a lengthy problem. We cannot really ascertain if it's 4. In this case, it works for 1 square, but we cannot necessarily say it works because we haven't filled the entire puzzle yet. All right? It could also be 1, right? Even if we switch it, let's see, even if we switch it, that's 1. I know it can't be 4, right? Right. It can't be 4 because 4 is right here. But this can actually be changed to 4 here. This is 9 right here. And this is 5. That still works because we haven't filled the other blanks, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. We haven't violated anything yet. But if we actually filled this entire grid, you'd find that there will be repeating numbers. So let's try to fill them with 1 in this case. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's try the vertical, this column right here, all right? Because it has the most number. So let's have a 1 right here. This has no 1 yet. 1, 2, 3, 4, 5 for this column. The 6, the 4 cannot be here also. Because the 4, let's try to exchange them. The 4 is already present. So let's try to exchange them with the 6. All right? So we're basically doing Sudoku here. So 1, 2, 3, 4, 5, 6. The 7 and 8 The 7 should be here because there's a 7 in this row. So 7, this is an 8. So that's already a complete 9 set of numbers. And so next is, okay, we have the most numbers here. Let's do this one. 1, 2, 3. You cannot have a 4 below. So let's have a 4 here. 1, 2, 3, 4, 5, 7, 8. Let's have a 9 here. Let's have a 6 right here. Okay? Yeah, imagine if this is in the test. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you'll also have a 1 right here. Let's just say that's a 1 there. We don't know yet. 1, 2, 3, 4, 5. This has a missing, this can't be 6. So that cannot be 1. Okay? 1, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 1, 2, 3, 4, 5, 6. This can be a 7 right here. This can also be a 9 right here. Those can be interchanged, right? So we fill this up. Let's fill up the most numbers. Which one is the most numbers? I think this one. Let's do this one here, the third one. So let's try a 1 right here and then a 2 right here. All right, so 1, 2, 3. The 4 should be here and then a 5 right here. 6, 7, 8, 9. Okay, 1, 2, 3, 4. If we have a 5 right here, 5, 6, and then a 7 and a 8 and an 8 there. All right, are we repeating numbers? Please do tell me if I'm repeating number. Next, 1 can only be here and a 9 can be here. So 1, 2, let's have a 3 right here. 1, 2, 3, 4 right here. All right, working. Everything works so far. Next, 1, we have the most number where? Here. So we have 1, we don't have a 2 yet. Let's put a 2 right here. 1, 2, 3, 4, 5, 6, 7, 8. That's a 9. All right. So from there, most numbers, we have 1, 2. We can place a 3 here. 1, 2, 3, 4, 5 can be here. 6, the 7 would be here, and the 8 would be here. Right? The 1 can be right. Oh no, there's something. Okay, let's change the 1 and the 6. Let's exchange the 2 and the 1. If this is a 2, this is a 1, the missing number here, but that won't work. All right? For a while. Is there any faster way to do this? Yes. Wait up. Yes, Nicolo.
I think I get it po. Is S1 po?
Yeah, S is equal to 1, but
Can
we
I
can...
annotate po?
You have you have an answer already.
Opo.
That works? Okay. You can annotate. I will now copy everything first. Okay. Please annotate.
Wait lang po. I I can't enable annotate po.
Pick up. It's in the mute and on and off video, what do you call this? Bars, toolbars. Please do check on that one. There's an annotate button there.
Wala po.
Wala. Wala. Oh no. There should be an annotate button, but I can't really see your screen right now, so I can't. Would you like to share the answer instead? And I will be the one writing it.
Okay po.
Sige. Let's start from the top left.
No po. Wait lang po. So, let's start in the middle square.
Okay.
The 3 by 3 square po. In the middle.
All right.
So, in the top, the one that has the 3 and 8,
Mm-hmm.
there should be one there beside 3. One should be beside 3 because in the other column there's like already one, and in the other square there, in the other 3 boxes there's like what a one in that whole box, so we can put it there. So that's we put one there.
Mm-hmm.
So second, so there's a 2 and 3 and 4 and 5. So next is 6. So since there's a 6 in the middle, like we can put it in the middle. We put it in the bottom right of the square.
Which one? What number again?
Bottom right of the middle square po, 6.
Okay. Go on.
There po. Then next is 7. Since we already have a 7 in the left of the middle square, we put it on the right. 7. So the last missing one is 9. So we put 9 in the square there.
Mm-hmm.
So since we got the middle square, it should be easy. Let's work on the top left square.
Okay.
So first we need to get 1. Since there's already a 1 here,
Yeah, this
there's
one.
already a 1 in
Here.
the left and 1 here, so we put it in the middle.
Yeah.
In the middle of the top left square. So yeah, there's already a 2. We only need 3. So we put it on the top left. Yes, top left. Top left square, because in the middle there's a 3 and the bottom there's a 3 also.
Mm-hmm.
So
Yes,
next.
this one and this one.
So I didn't get the 4 because there's not too much clues. I moved to another square, the middle in the bottom.
Mm-hmm. This one.
Yes po. And then first I got the 1, which was easy because there's already 2 ones.
Yes, this one and
And
this
then
one.
since there's a 2 and a 3, next we get 4, and there's already a 4 here and a 4 in the
Yeah, a 4 here and a 4 here below.
yes. Next is 5, which is already given, and then 6. So the 6 goes to the bottom left because there's already a 6 in. Wait lang po. There's already a 6 in 2 squares. There's already a 6 in this column.
Yeah, this one.
I'm still thinking why I didn't put it here. But anyways, I put it right there, the 6 in the bottom left. And then the 7 goes in the middle because there's already a 7 in the bottom.
Yes.
And then 8. And then the 8 goes right there Oh, that's why I didn't put it there, the 6. I
Mm-hmm.
put the 8 there so it doesn't like that's the only square that doesn't get blocked. So we put the last 9. Since
Yes.
we already completed 1, 2, 3, 4. The fourth column from the left, from the right, which has the S. This is 4 because we can put 4 here. This is 1 because we can put 1 in that column. So S is 1 and below it is 4. So that's how I got it.
All right, great. So yeah, a good thing you found that out. So that is our answer. All right. So we've um minimized as much uncertainties and doubts here. I think that was enough explanation for one. All right. So that's it. You have 50% chance to get this answer because you were choosing between 1 and 4. First, make sure to cancel out every possible number out there. Okay. So that's it. Thank you so much for number 16. Let's have number 17. So for number 17, according to the following sequence, what is the unit digit of the 2013th number? So notice that we have a 2460, and then a 6628. What's the pattern? The pattern is times +2 +2 +4 +6. Yes. Was that raising their hands? Alan, do you have something to say?
What time is our break today?
Oh, all right. I thought you're gonna answer. The break will depend if we finish 18. That's after number 18.
Oh,
Lucas, do you have anything to say?
It's, if you can see, it's 6 minus 4, 2. 10 minus 6 is 4. 16 minus 10 is 6. 26 minus 16 is 10. 42 minus 26 is 16. And 68 minus 42 is 26. And so on and so on.
All right. That's great. Any idea what's the answer?
I don't know the answer.
All right. So here it's actually okay, 2013. Um, we don't really have a distinct short pattern here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. We don't have a pattern here until you get to the 20th term. All right. And then after the 20th term, you will see it being repeated, the 20 unit digits. All right. To show you for a while, it's number 17. Okay. It's this one right here. So this is, oops, and this is the 20 unit digits if you continue increasing the number here on the screen. All right. So this 20 unit digits, after the 21st, it will now repeat again. So if that repeats, that means we have a pattern. And if we have a pattern, we can answer this by having, okay, it repeats every 20th digit, right? So the 2013, divide it by 20, obviously, we will have a, what do you call this? We will have a number that's equal to 100. 20 times 100, 2,000, right? So 100 remainder 13. Kasi it's 2013. Okay, and we want the remainder. So let's count from the first one. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, this is our 13th number. So the answer is actually a 4. All right. So yeah, a unit digit problem, we just need to really find a pattern. Do not give up until the 20th because 20th is still a possible set of numbers that will be repeated. All right, that's it for number 17. Let's have number 18. Chung has 24 books and Fong has 64 books. How many books does Fong give to Chung? So such that the number of Chung's books is 9 times more as that of Fong's. So to answer this question, again, let's add up all of their books. That's 24 plus 64 and then divide it by divide it by 11. And then that's equal to 8 because we have 88 divided by 11. That's 8. So 64 books of Fong. How many is he giving to Chung? That would be 64 minus 8. All right. 64 minus 8. 64 minus 8 is actually 56. So you have 56 as an answer. Yes, Lucas.
In the problem, it says 9 times more is that of Fong's, but in the paper, it says 10 times is that of Fong's.
Oh, it's the paper. It says 10. All right, let me double check that one. I think that is indeed 10 times more. Okay, so that the solution would be divided by 11. But if it says 9 times more, that means to say, okay, let's follow the 10 times more because this is what is working. But if ever the problem says 9 times more, so you will have 9 plus 1, this should only be a 10. All right? But since it says 10 times more, there should be 10 times more. And then that's an 11. Okay, let's follow the paper you're answering. Question. All right, please stop spamming the chat box, please. Anyone who has a different answer. 11. We need to divide it by 11 because it says we're trying to evenly divide it between Chung and Fong. It says it has Chung must have 10 times more, right? So if Chung has 10 times more, Fong has only 1. Okay, so 10 plus 1 is 11. All right, but if it says 9 times more, that should be divided by 10. All right, question. Okay, no question. Let us proceed to the next number. Okay, so let's just have a very short break. Let's be back at 2:25. 5-minute break. All right. Is everyone back? Okay, let's start, everyone. So again, let's continue with number 19. That was just a short break. Yes, queries and concerns on the chat box, please. Please do tell me if you don't have the same question. All right. So we have number 19. So for number 19, let's start. Find the value of E in the following sequences. Anyone who wants to answer? Yes, Steven.
Plus one.
Oh, we can hear your voice clearly, Steven.
1 plus 1 is equal to 2.
Okay.
2 plus 1 is equal to 3. 3 plus 2 is equal to 5. So 8 plus 13 is equal to 21. So 21 is the answer.
Right. So for this one, that's basically how we do it. Identify the sequence and then we get our answer. For number 21, it is no, not 21, sorry. For number 8, not 18, but 19, it is 21. All right. So that's it for that question. Let's proceed to the next one. Anyone who has an idea? Okay, this number, question 20. Okay, no one has an answer. So the figure below is a route map. Each straight line represents a road, meaning needs to walk past all roads once. If you can start from any point, how many meter is the shortest path for me? All right, so there are 7 roads. So what we can do is actually 7 plus 6, and then plus 2 plus 3 plus 5 plus 6 plus 2 plus 4. All right, this one. So that's a total of 37. Okay, let's put it right here. The answer is 37. Okay. Again, to show you the solution, it's like this. Yes, Lucas, do you have something to say?
We have different numbers. It actually says 2 and 3 there, but in our paper it says 1 and 1.
Really? Oh no. So in number 20, no, 20 it says 23, the middle one, the one in the center. Is that right?
Teacher, iba po yung nakalagay dun sa, dun po sa,
What does it say?
it says 2, the 7 and 6 is 2 and 5, the 2 and 3 is 1 and 1, The 5 and 6 is 5 and 3. And the 2 and 4 is a 2 and 4. So the only correct thing is the 2 and 4 and 5.
Okay. For a while, ha? Okay. So for that, then let's stick to what's given muna here. All right. So I'll clarify that concern with my fellow workmates. Okay. So we have here, again, this is the process of doing it. We have the 7. Okay, take into account everything. You'll have the 7. Okay, the 6, the 7, the 2, the 3, and then the 4, the 2. You'll also have the 5. Okay, let's 7, 6, 2, 3. They went through here. 7, 6, 3, 2, and then the 5, and then the 6. The 6, and then the 2, and the 4. And there's no 2. It's actually should be 3. Yeah, I think the shortest way is like this. So if we go through here, okay, 7, the 6, the 4, the 2. Oh, we'll go back. No. 7, 6. Let's have the 6, the 7, the 5, the 2, the 4, the 3. No, that was the most efficient earlier. So we'll have the 7, the 6. Yes. 7, 6. If we have the 6, the 5, 7, 6, the 3, the 2, okay, or the 6, 7, 2, 3, the 4, the 2, the 6, the 2, and the 5. Yeah, that's how we do it. That's the most efficient way. So again, the 7, the 6, the 3, the 2, and then this one, and then this one. All right? So 7, the 6, the 3, 3, 2. If you have the 3, the 2, the 6. Okay, let's have the first one here, the second one here, the third here, the fourth path here, the fifth one here, the sixth one here, the seventh one here. We go through the least number twice. All right. So that's the shortest path we could go through. So this is the 8 still, and this is the 9. All right. So 7 plus 6 plus the first one was 3 plus the 2 plus the 7 plus the 6 plus the 4 plus the 2 plus the 6 plus another 2. We passed that number twice, and then plus the 5. All right? So we pass through the we want to pass through twice the shortest distance, right? Because that would mean we have the shortest path traveled. Excuse me. So 3 plus 2 is 5, plus 7, that's 12, plus 6, that's 18, I know this is 12. This is already 10. This is already 10. And this is 5. So we have 10, 20 plus 12. That's 32 plus 5. That's 37. That is the shortest path described right here. All right. So again, we want to pass through the shortest distance more times as possible if you were to cross twice. All right. So that's it for 21. Let's have 22. The figure is a street map. Postman could start at any corner on the street. If postmen have to walk past all the streets once in order to mail all letters out, at least how many meters are required for postmen to walk? All right, basically somehow the same problem with earlier. So we have this one. So we have 3. Okay, again, we're gonna pass through also the least distance possible. And we can have that by having this one right here. For number 21. Yeah. So we pass through 3 and 4 twice. All right. So again, we have 3, 6. Okay. If you're gonna pass through here, okay, 6, 7. Three plus 4 plus 6 plus 7. All right. Again, 3 plus 4 plus 6 plus 7. And then you're gonna pass through another 3, 4, 6, 7. And then you have to pass through this 3 again, right? But if you pass through here, you'd have a big distance of 7. So let's not do that. We want to pass through the shortest side as much as possible. So again, let's go back. 3, 4, if we do here, if you do this one here, 3, 4, 6, 7. Okay, 3, 4, 6, 7. And then you'll pass through 4, 7, 6. Let's 7, 6. Let's pass through 3. Okay, that's 6, 7, 3. But we're gonna pass through this one twice. We can't do that. Let's start at the center. Okay, so we have 7, 6. If we're gonna pass through here, 7, 6, 4, 6, 7, 4, 3. Okay, we're going there, there, and then there, there. And then this one right here, we're gonna pass through here. And there's a 6 right there. We don't want that. We want to pass through 3. Okay? So to pass through 3, okay, let's start at 7. Then let's have 4. And then let's have 7. And another 4. And then 3. Okay, 7. And let's pass through here. Passing through here. We'll pass through here twice. But we're gonna add the 6. That's not... Okay, we already have a 7. 1, 2, 3 sevens. And then we have 1, 2, 3 fours. passed through. That's good. 1, 2, 3 that we passed through, but we're gonna pass through 3 again, and 4. It seems like I'm going the wrong way. If we start here, we're gonna go up here and here, and then here. We're gonna pass through this one, and then here. And then down here, and up here. And we have to pass through 6 if we're gonna do that. So 3 plus 4 plus 6 plus 7. We have a 3, a 6 there. Yeah, I think this is one. We haven't repeated yet except for 3 and 6. Okay, if we add them up, we'll have 7 plus 6, 7, 14, 21. That's already 21. 6, 12, 18. This is 3 plus 4. That's already 7. This is another 3 plus 4. That's 14 in total. Right? That's 14 in total. 18 plus 21 plus 14. We have 53. If we're gonna pass through this right here, that's plus 9. That's already 62 plus 7. All right. So we're gonna have okay, let's do it like this. It's still a big number. I think we can still, we're passing through 3 and 6. Let's try to really pass through twice 3 and 4. Let's find for that. Let's look for that path. All right, if we do this, we can't pass through 7. We'll pass through 3 and 6 still, right? Pass through here, pass through here, and then there, and there, and then here. Essentially, we're gonna pass through 6. Okay. Going around it. Gonna have 6. We're gonna end up at the same spot. Okay, let's pause this one for a while. It seems that I'm having something amiss. Right? Something's amiss. We have to find the shortest way possible, but I can seem to find it for a while. Let's pause this question, postpone this question for a while. Let's have the next one instead. Let's get back to this later. So for 22, we have this type of question. 49 plus 13 raised to 3, raised to another 3 again. So again, we just want the unit digit. If you add 49 and 13, you will get 62. So 2 is the last number. Let's get the pattern for that. So we have this question. Again, 49 plus 13 is 62. 4 plus 1, 5, but we have a carried 1, so that's 6. So 62 raised to 3. We just want the unit digits, so we're just concerned for 3. We have a power rule. That means to say that when you raise a number to a certain m, or a certain exponent, and then you're raising that to a certain exponent, you can actually just multiply that one. M times n, it's just equal to 8 raised to m times n. All right, so 3 times 3 raised to 3 is just 2. 3 times 3 is 9. So remember, our pattern of 2 is 2 raised to 1 is 2. 2 raised to 2 is 4. 2 raised to 3 is 4 times 2, 8. 2 raised to 4, 2 times 8 is 16, that ends with a 6. And then 2 raised to 5, 2 times 6, that ends with a 2. And if you continue doing that until you get to 9, all right, so you'll end up with a 4 again, and an 8, and a 16. 6, 7, 8, and then the 9th, you'll go back to a 2. So the unit digit for number 22 is a 2. All right. So yeah, that's it for this question. Let's proceed to number 23. For number 23, we have a 4-digit number, 85C5, divided by 3 gets a remainder of 2. What is the maximum value of this 4-digit number? So to get, if it's divided by 3 and has a remainder of 2, so you'll have 8 plus 5 plus C plus 5. It's divided by 3. 8 plus 5 is, no, 5 plus 5 is 10, plus 8, 18. So you have 18 plus C. So C can only be, 18 was already divisible by 3. So to get a remainder of 2, we can have a C, 18 plus C. C must be equal to 2, a 5, or an 8. All right, so that we get a number that is when divided by 3, we'd get a remainder of 2. Just like 18 plus 5 is 23. 23 divided by 3 is 7, remainder 2. So we still have a remainder 2. So yeah, we could have 2, 5, or 8, but we want the maximum value. So we will have 8, 5, 8, 5. All right, so that's it for our answer for number 23. Let us proceed to the next number. We have 24. So for 24, the question is, find the value of this expression right here. It's just the same with what we had earlier. So we could have a sum of an arithmetic sequence formula. Remember, we can just multiply it by 2. Or we could actually have this kind of solution right here. Okay, this one right here. So we factored out the 3, and then we have 1 to 19. Okay, when you add that, 19 plus 1, 20. Okay, then divided by 2, and then multiplied it by 2 plus 60, because the 60 is paired. You multiplied it by 2 because there are 2 sequences like that, right? So this one, the first set of sequence and the second set of sequence. That's why we multiplied it by 2. This one, this is just the arithmetic sequence formula, right? This part right here. And then you add 60 because we have 60 that is unaccounted. So 60 times 2, that's 120, 1,200. 6 times 2 is 12. Copy the 2 zeros. That's 1,200. All right. So if you have questions in the chat box, please. So if none, let's proceed to 25. So 25. So for number 25, find the value of g in the following sequence. So this one, adding the last three numbers, right? So 1 plus 1, 3. 1 plus 1 plus 3, that's 5. 3 plus 5 is 8 plus 9, 17. So we just need to add the last three to get g. 17 plus 31, that's 48. Add 57, you'll get the answer of 105. All right? Add the last three. Numbers, not digits. Add the last three numbers. All right? If you have no questions, let's proceed to number 26. For number 26, there are four integers. Calculate the sum of any three numbers and then minus the remaining number to get four numbers, 63, 95, 99, 109. What is the original sum of these four numbers? All right. So for a number like this is, okay. To do this one, we can just actually add these four numbers indicated here and then divide it by 2. All right? And you'll get the original sum of these four numbers. So we have, for number 26, this is our solution to get the answer. So 63 plus 95 plus 99 plus 109, and then divide that by 2. You will get 183 as an answer. That is now the original sum of the four numbers. All right? Proceeding to number 27. If you have no questions, in the chat box, please. All right? None so far? Okay. So if there's none, let us have the next one, 27. So for number 27, it's actually a pattern question again. Notice that the pattern is every 8 set of this 1, 2, 3, 4, 5, 6, 7, 8. Yeah, and we're repeating the first one. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that one. So the process is just 2012 divided by 8 to know how many sets of that is occurring. So 2012 divided by 8, you'd get an answer of 251. Excuse me, remainder 4. All right, so if you have a remainder 4, remainder is what matters here. It means you are at the fourth object, but it's color that we're asked for. So the fourth color is 1, 2, 3, 4. It's black. All right, so it's actually the black square. No questions. Let's proceed to number 28. Okay, for number 28, okay, we have this question. This time, what is the 1003rd figure with color? Okay, so it's actually the figure and the color we're asked for in this one. So I think it's the same. I know it's not the same pattern. Careful. So it's not the same pattern. It's actually every 12 sets this time. Let's see. So this one, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, notice, and it's being repeated right here and being repeated so on. So 1003 divided by 12, you'd get an answer of 83, remainder 7. All right, so it's the remainder that matters. Let's count which is the 80, which one is the seventh? 1, 2, 3, 4, 5, 6, 7. So it's actually the inverted triangle and the white inverted triangle. All right. So that's it for number 28. If you have no questions, let's proceed to number 29. Please refrain from spamming the chat box so that I can still see the questions. Okay. So for number 29, we are asked here that we have a sequence. What is the unit digit of the 500th in the sequence? So the pattern is 1, 3, 4, 7, 1, 8, 9, 7, 6, 3, 9, 2. All right, and we're gonna repeat that one. Okay, here is our pattern. All right, so notice that the pattern is being repeated every 12th number. Okay, 12 numbers in that pattern. So what we're going to do is 500 divided by 12 because we're just going to repeat it with between this number 5, 6, 7, 8, 9, 10, 11, 12. And notice it's being repeated, so on, right? So 500 divided by 12, we'd get an answer of 41, remainder 8. It is the remainder that we are after. So 1, 2, 3, 4, 5, 6, 7, 8. It is the unit digit of the 500th in the sequence is 7. All right. So that is it for that number. Let us proceed to the last one. Okay. Okay, for number 30, it says after forming 1/7 into the decimals, what is the 200th digit after the decimal place? So let's check what is the repeating pattern of this decimal value. All right, so 1/7, when you divide that one, you'll get values of like this. Right? It's 0.142857142. To give you an idea how to do that, it's actually like this. So 1 divided by 7, all right? There is no 7 that will fit in 1, so that's 0. Put a decimal point, you can also add a 0, so that's already 10. 10 divided by 7, there's 1 7 there. 1 times 7 is 7. Subtract 10 minus 7 is 3. Add another 0. 30 divided by 7, that's just 4. 4 times 7 is 28. Then this will become 2. This is a 0. Add another 0. That's 20. And you'll have 2 and so on. That's how we do it. Okay? You'll eventually find that this is your answer. So notice that you will be repeating 142,857, and then you have another 142. So that's a set of 6 numbers. So 200 divided by 6. 200 divided by 6 will give you an answer of 33 remainder 2. That means to say it is the second number that we are gonna end up with. So it is a 4. All right, so it's a 4. The answer for number 30 is a 4. All right, questions so far, please in the chat box. Are there none? Yes, Earlja.
Can you repeat number 1?
Oh, all right. Since we're pressed for time, we're actually already beyond our scheduled time. we will be sending you a recorded video where you can watch and repeat. Where you can watch that video, okay? So yeah, no other question. Okay, if you have no question, okay, let's just go back a little bit because we haven't answered yet what number was that? This one. So it seems that there's something different with the solution. All right. So let's stick to this one. The only solution I could find is where we pass through 3 and 6. So this one. Okay, let's pass through 7 and 6, 4 and 6, 7, 4 and 3, 7 and 6, and then 3 will pass through 6. Oh, we can't do that. Earlier, where we passed through, okay, 7, if we're gonna pass through that one. If we start from the center, 7, 6, go back here, and then go up here, and then pass through here, and then here. Okay, let's pass through the smaller ones first. Here, going up here, and then here, and then here, and then here. If we go through 4 and then 6, that would make it a big number. Yes, Lucas, you have something to say?
I found something faster.
Go on.
It's
Where do we pass through? You can mention it. I can go through the.
so that's uh the starting point is here.
Okay.
You go here and then down here. Uh and then you just go up, go to the right, turn around and go back up there and go to the right and here.
Oh, but we're gonna pass through 7, which is a bigger number. I think that 6 and 3 is more suitable. Anyone else has an idea? The faster way. Earlier we had, where did we pass through earlier? Let's pass through 7. If we're gonna do this, let's erase all the drawings. Yes, Lucas. I found it. I think it's this one. All right, I found it. So here, notice that we only passed through 4 and 3 twice, right? So it's only this one right here and this one. Okay, so it actually works that we have, let's start with the first one. It's 7, 14, 21. Okay, we have 21. 6 plus 6 plus 6, that's 18. We have 4 threes in total that we're passing through, so that's 12. And then we have 4 fours we're passing through because we passed through this 4 twice. So that's 4 times 4 is 16. So from there, you have, okay, let's add them up. 18 plus 21 plus 12 plus 16, that's 67. All right, great. We finally found it. Okay, questions. Okay, we started here and then went up and then right, down, left, going up in the middle, and then left, going down, and then going to the right and up again in the middle and going to the sixth one. And that's it for our number 21. Did we miss anything else? None? Questions so far? No question. Okay, so I think that's it for our session today. So if you have any questions, that's it.